to the next talk, which we should have somewhere, Steve from Desmos. So we're kind of moving on from thinking about how we make convert materials to the additional functionality HTML materials give us. And Steve Clower from Desmos, hello Steve, there you are, is going to talk us through some examples there. So thank you, Steve.
All right, thank you. Is everyone able to hear my audio? All right, I will assume no response means yes.
Yes, we can.
All right, good. Good afternoon, everyone. Name here is Steve Clower. I am the accessibility specialist at Desmos Studio. I've been here for just over 10 years. And at Desmos, we've got a simple statement, or our vision rather, and that's we want to help everyone learn math, love math, and grow with math. And yes, I say math, that's how we say it here in North America. I know it's maths in the UK. Might be more technically correct, but it sounds strange to my ears, so please forgive me for using the American term here. Anyway, we make freely available cross-platform HTML5 based tools, including a graphing calculator, geometry construction tool, 3D modeler, four-function calculator, scientific calculator, and a matrix calculator, all of which are freely accessible online at www.desmos.com. That's DESMOS.com. We also have apps in the Apple and Google Play stores. So we run on pretty much any any modern piece of technology, which is actually one reason why I wanted to work here back when I applied, because if you make something accessible, it's going to be accessible on a lot of other platforms, which has historically been a problem, as I'm sure most people know. One thing that we did release in public beta a couple of weeks back, which we're not going to have time to demonstrate, but I strongly encourage people to play around with, is a new product called Desmos Notebook, www.desmos.com/notebook. And the idea between Notebook is it allows you to combine our existing tools along with, kind of free-form prose text. So, for example, you could make a document which includes text and embedded graphs or geometry, things of that sort. Think of it as kind of a word processor for doing math. Anyway, we'd love feedback on that. Like I said, public beta. But we're not going to go through that today. In the interest of time, I don't think I'm going to be able to show too much of our tools, but I do want to give kind of a quick overview of sort of our bread and butter tool that's been around the longest, and that is our graphing calculator. So give me just a moment to get sharing working here. All right, and you will hear my screen reader, so hopefully I've got the balance reasonable here as well as the speech, the speed. If anything is hard to understand, feel free to interrupt, let me know. That's not a problem. All right, sharing.
Desmos graph.
All right, so I'm currently in the Desmos graphing calculator. The first thing I want to show is just kind of a very basic concept, and that is our talking equation editor. Sounds like a simple idea. It's surprisingly not so simple or easy to implement, but I think we've done a pretty good job here. So I'm currently sitting inside of an expression in what we call our expression list. You can have more than one. I'm just going to type something very simple, 2 plus 2.
2 plus 2. 2 plus 2 equals 4.
And you could hear the screen reader echoing my keystrokes. as well as the evaluation when it showed up on the screen. So we heard 2 + 2 = 4. We can do something a little more complex than that, of course. I can change this to, how about, I don't know, let's do 2 pi.
Pi. 2 pi = 6.28318530718.
And then we have the evaluation spoken again, and we also heard it say 2 pi. One thing that we also do here that I will show is that we are able to kind of make some educated guesses as to how to pronounce mathematical expressions. So a couple things that we have here is, if we want to write a fraction, I can do, how about, let's do 1/2.
1/2. 1/2 = 0.5.
So we said 1/2 as I was typing that, and then we pronounce this as 1/2. This shows up as, the standard fraction 1/2. We could do the same thing with
selection removed.
We can do 3/4.
3/4. 3/4 = 0.
And we hear 3/4. We do this for, all kinds of ranges, basically 1 to 12, and I think 100. But anything more complex than that, we will speak, standard fraction notation. So if I do y equals x over 23.
Y = start fraction x over 23 end fraction as graph.
And we'll hear y equals start fraction x over 23 end fraction. And then we also hear that it has a graph. We'll show you how to explore graphs in a moment. So all that to say, we do have an accessible equation editor. It looks nice in print. And shortly, I will also show you how you can access the same information in real-time Braille. Before I do that, do we have any questions?
Any questions before we move on? I think we might keep questions for the end. Thanks.
All right, fair enough. All right. So jumping in to the next bit here, let's show you how to work with graphs. Probably the simplest way, we've got a feature called Audio Trace, which allows you to graph an equation and explore it through sound. So I'm going to make what's probably the simplest graph out there. It's just a straight line of y equals x.
Equals x. Y equals x as graph to audio trace, press Alt + T.
And we heard that this does have a graph, and we're given instructions on how to enter what we call audio trace mode on a Windows PC or a Chrome device, or basically anything that isn't made by Apple. We will use Alt-T. If you're using an Apple device, the command is Option-T. And if you're exploring the user interface with the touch screen, for example, with TalkBack on Android or VoiceOver on iOS, there's a keypad also on the screen. You can find the buttons, and there is a button in the bottom left corner that allows you to go into Audio Trace as well. Since I'm approaching this from a Windows perspective with a full-blown keyboard, I'm going to use Alt-T now to turn on Audio Trace.
Audio trace on. Use arrow keys to navigate. To hear the graph, press H. To disable audio trace, press Alt + T.
And now we are on the graph. We were given some basic instructions. I can press H to hear the graph. I can also use my arrow keys to explore kind of sample points along the curve and kind of hear where those things are in real time. So before I explore, I'm going to press H, and here's what happens. I'm not sure how well that translated over Teams, but basically what we just heard was a tone sweeping from kind of a low pitch to a higher pitch. And there were some cues in there that probably got lost. We played some static while Y was below 0. And then the timbre, or the overall shape of the tone, kind of changed when we got to X above 0. Or excuse me, Y above 0. And if you have headphones or speakers, you also will notice that the tone sweeps from left to right in the stereo field. So it kind of gives you some spatial orientation to what the line is doing. So I'll play this one more time for people to hear it. So there's our graph. Can also use arrow keys to explore. So right now I'm centered at the origin here at 0, 0, just by default. I'm going to press the right arrow key.
X 0.2, Y 0.2.
And we heard X 0.2, Y 0.2.
X 0.4, Y 0.4.
And same, X and Y are going to be the same in this case because we have Y equals X on the graph. A few commands I can give here. If I want to have the X or Y coordinates repeated, I can literally press those letters on my keyboard. So X
0.4.
Or I can press Y
0.4.
And if I want to know what color this is for any reason, I can hit C.
Red.
Here that it's red. We can also find out what type of a point I'm on with the letter T.
Not a POI.
Not a POI, point of interest, which is correct. So just to give a little bit of contrast, I'm going to next.
Expression 2.
I turned off audio trace with Alt-T, which put me back into the expression list, and then I hit down arrow. Now we have a new expression line. I'm going to do Y equals minus X.
Y equals negative X.
Or negative X.
Y equals negative X as graph.
All right. So now we have two lines, one straight up, one sloping up, one sloping down. Going to go back into audio trace with Alt-T.
Audio trace on. Use arrow keys to navigate.
And now I'm going to play this, and we get a line that starts high on the left, ends up low on the right. So one of the things that we can do for navigation with graphs is if you want to go specifically to points of interest that we are able to identify, you can use Tab and Shift Tab. So arrow keys are kind of like moving through characters in a word processor. Tab and Shift Tab is kind of like moving through the big points or the controls, that you might have in a dialog box. So I'll hit Tab to move forward, which there should only be one thing that I'm already on.
No more points of interest 0. Intercept and intersection with expression 1 at X 0, Y 0.
So we heard a few things here. Speech-wise, we heard that we're on a 0 or root, an intercept, and intersection with expression 1 at X0, Y0. We heard a brief tone to indicate where we were in the spatial field. We also heard a brief pop sound, and the pop sound indicates that we are on an intersection with another curve. And I realize this is a lot to try to take in here in the brief time we've got. Don't worry, we've got documentation and resources that I will share when we're wrapping up. All right, one other thing I want to show is
audio.
Let's show what happens if we graph something like a circle. So I'm going to do X squared.
X super 2, baseline plus Y super 2, baseline equals 9. X squared plus Y squared equals 9 as graph.
And we heard some mathematical shorthand again, like we showed with fractions for the exponents here. So instead of X superscript 2, N superscript, Y superscript 2, and superscript, we're just hearing X squared and Y squared, which is how you would say it. All right, back into audio trace with Alt-T.
Audio trace on. Use arrow keys to navigate.
Control to silent speech. I'm going to press H to explore this graph. All right, you might be wondering what just happened. So the graph of a circle actually creates two solutions, a positive and a negative. And pressing H allows us to hear both of these at the same time. So the lines kind of start together, sort of spread apart, and then kind of come back together when the graph ends. So visually that makes a circle. If you want to explore each what we call a branch or solution, you can of course use left and right arrow keys to go across.
X 0.2, Y 2.99333. Last point 0 at X 3, Y 0.
So there's our top branch. I was just using the right arrow key to navigate, and I can use up and down arrow keys to go between branches.
Branch 1, 0 at X, 3, Y, 0.
So now moving left along the bottom half of the circle.
X, 0.6, Y, negative 2.93939.
We've got that. And if you want to hear the individual branches, which is actually something we used to do by default, you can press the keys 1 through 0. That's the figure 1 through 0 on the num row on the keyboard. So 1 will play the top branch. 2 will play the bottom branch. So there's those. And okay, I think that's about all time we've got for the graphing part anyway. Yeah, so we're getting close to time here. So I'm going to turn off audio trace now. A couple things I want to show very quickly are our ability to go into Braille as well as show large contrast modes. There's a couple ways to do this. I'm going to open our graph settings with Control-Alt-G.
Graph settings dialog.
I'm going to tab through here.
Reverse contrast checkbox not checked.
So we'll start with reverse contrast because we're here.
Checked.
And this essentially inverts the graph. This is not a full dark mode. That is coming, but we don't have that in just yet. We'll turn this back off.
Not checked.
Tab over to
Braille mode checkbox not checked.
Braille mode. I'm going to check this with the spacebar.
Checked.
And then we can go to
Braille mode grouping. Nemeth radio button checked 1 of 2.
We currently support 2 Braille codes, Nemeth, which is very popular here in North America, as well as Unified English Braille, UEB.
Web radio button checked 2 of 2.
And we'll leave this on UEB. I'm going to press escape to go out of the settings.
Graph settings controls region.
And back to our expression list.
Expression list region. Ec number edit Y7X.
All right, ignore what speech is saying, but what we're showing visually, as well as if you navigate with a connected Braille display, is our entire expression list has been rendered in Braille. So if you've got access to Braille hardware, this is a way that you can take advantage of that. And what's nice here is that this is done on the fly. So if you have a link that someone sends you, or you want to send a link to somebody else to use, or if you embed a graph into your own content, a student that needs access to Braille will be able to get it without you having to do anything extra. We also do support embossing graphs to devices like the Romeo and the Juliet from Enabling Technologies and Humanware, the View Plus embossers, and we've got some hopefully exciting news to share soon about some additional tactile graphics support. One last thing I want to show is how do you share a graph for potentially embedding inside content, or if you're working with a student, how you can get work to them or they can get work to you. We have a share menu at the top of the screen. For the sake of time, I'm just going to use our keyboard shortcut, which we have a lot of. Control-Alt-S.
Share graph dialog. Share a snapshot button. Share graph.
So I'm going to choose to share a snapshot. So this will be what my graph looks like right now. Whereas if I share just a regular link, it would be, any changes I make will just show up in that link.
Desmos share graph dialog. Link to this graph edit selected.
So we have a link to the graph that I can literally just copy and send off to somebody.
Copy button. Browse mode.
We can copy that to the clipboard.
Embed snapshot heading level 2 button collapsed.
And we also have instructions for how to embed this snapshot into a website using an iframe. We won't go into those details, but they are here if you want to explore them.
Teams.microsoft.com is sharing the.
All right, and I'm going to stop sharing here because I know we're already past time. A few resources I do want to point out that are available to you. Of course, www.desmos.com is our main website. If you're interested in the accessibility specific pieces, you can go to desmos.com/accessibility. And we do have a large number of keyboard shortcuts available throughout our products. Available on the accessibility page, but you can also get to them at desmos.com/graphing shortcuts for the graphing calculator, geometry shortcuts for geometry, and 3D shortcuts for our 3D construction tool. And if you have the need for them as you're using our tools, at any point. You can use kind of the universal key that's been accepted here, which is Control/ on a Windows device. That's the /, the one pointing to the right. Or if you're on an Apple device, Command/. Finally, if you want to get a hold of our accessibility team, which is probably mostly going to be me if it's through email, you can email accessibility@desmos.com or find us on your favorite social media platform of choice, including YouTube, where we do post videos on some more advanced topics. All right, I think that's
Desmos
it for
graphic
me.
calculus
So
teams.microsoft.com is sharing Teams hide link.
I will turn it back over to the presenter.
Thank you very much, Steve. Transmitting the
Speech mode off.
applause, which was also nice suppressed. That was great. Thank you very much. Have we got any questions for Steve before we break for lunch? And as usual, if we don't have time for your question, write it on a post-it note, and we'll get back to Steve later in the afternoon.
Thank you very much, Steve. I've enjoyed playing with Desmos, but what we're finding in higher education is that some of the maths won't fit in Desmos.
Yeah,
the complex maths, yeah.
Okay. That's interesting. Yeah, if you are around this afternoon for kind of the more freeform session, I would love to learn more about what trouble you're experiencing, see what we can do for you.
Anyone else? Okay, that's probably quite a good. Another question.
Thank you. I'm just wondering, is the screen reader AI generated sort of? Is that AI that powers that?
No. This is all done client side. There's no AI involved whatsoever.
There was a question in the chat as well about the screen reader, which follows on nicely from that, about whether the screen reader was happening that we could hear on our end, whether that was Desmos or whether that was your local screen reader interacting with Desmos, and sort of where the boundary was between those two.
Good question. It's actually both. So what we do is we leverage existing APIs and screen reader tools that already exist. So for example, we're not doing anything special to announce things as you, for example, tab to them in the main interface. We just label expressions, expression 1, expression 2 with ARIA. We use standard buttons and things like that as you're tabbing through things. We communicate state changes to custom items like our checkbox component. So that's just communicated naturally to allow you to customize how your screen reader presents it. For more custom things like the talking equation editor, as well as everything that we showed through audio trace, all that speech, that is generated from Desmos, but we are communicating that through ARIA live region changes. So the screen reader, it's still going down the screen reader's pipe, so to speak, but it's not something that will interfere with a user who is not relying on a screen reader. For reference today, I was using NVDA and Chrome.
Amazing. Thank you.
Okay.
On that note, thank you, Steve, again.